Hello class, we're about to start the exam 1 review for Math 30. So first we go here to lesson 1C. Now this correlates with your lesson 1C from your course pack and also My Math Lab. So if you need extra practice, whatever the lesson is, you can refer back to your notes or go to My Math Lab for more practice. Okay, it says number 1. Well, actually instructions. Justify all answers with mathematical work or written explanations. A popular drive-in food stand advertised that it could provide 1,063,953 fountain drink and slush combinations. Approximately how many drinks per minute would you have to order to sample all possible beverages in 1 year? Okay, now we need to look at a couple key items here. First of all, we said the question is how many drinks per minute would you have to order to sample all possible beverages in 1 year? So the word per we know means division. So we know in this problem we're going to end up dividing. So the first thing that we need to do is this here. We know how many fountain drinks there are, which is this, well, combinations, 1,063,953. But we need to find out how many minutes are in a year. And so this is how we would do it. We know there are 60 minutes in an hour, and then we will multiply that by 24 hours in a day, and we will multiply that value by a standard year, which is 365 days. Now, when we multiply this out, this will give us 525,600 minutes. Now, this is how many minutes are in a year. So now what we need to find out is how many drinks per minute will we have to get in a year in order to have all of these drink combinations. So what we would do is we would take this 1,063,953 and divide it by how many minutes we have in a year, which is 525,600 minutes. Now, when we put this in a calculator, let's pull up a quick calculator here. We'll put this in a calculator, 1,063,953 divided by 525,600. And this will give us a little over 2, so we will approximate, so it will be approximately 2 drinks. So this will be our final answer. So now, we come down here to number 2. It says the chemical diacetyl is a natural flavoring that gives the taste of butter. A human can distinguish the butter flavor with 5 ppb parts per billion. 1 gallon is approximately 75,000 drops of water. How many gallons of water are equivalent to 1 billion drops? Okay, so what we will need to do is this here. We are going to have to divide, because what we have here is that 1 gallon is 75,000 drops of water, and we wanted to know how many gallons of water are equivalent to 1 billion drops. So what we would do is we would take 1 billion. We know 1 billion has 9 zeros. And then we would divide it by 75,000. Now we could put this in our calculator. So we will have 1 billion divided by 75,000. So now if you notice here, we have 13,333 and this decimal here. So what we would have to do is pick the answer that is closest to this, which would be the 13,000, which would be A. And also I made a mistake on problem number 1. I should have circled C, because that would be your final answer. Now, one other thing. I was asked this in a previous class. Some people say that their calculator cannot take these numbers because they're too long. So this is what you could have done if you run into that situation. So we could shorten the number, especially for numbers like this. we'll rewrite this as a fraction. And you notice that both of these numbers ends in zeros. So what we could do is this here. However many zeros they have in common at the end, we could cross them out, which is a form of simplifying. So this will end up being 1 million all over 75, which is a smaller number that you could put in your calculator. Let's test this to make sure that it's correct. And it comes out to be the same value. So this is a way how you could shorten it if you have a calculator that cannot take very long numbers. Now we're going to move along to lesson 2A. It says instruction, justify all answers with mathematical work or written explanations. Below is a table showing how annual household income has risen in the past several decades. I have that same chart here. Now, if you notice, I could not show the year and annual household income, but as you all see, it's right here. And I did not have it for 2012. See if I could get it up to 2012. Okay, it's very close. If we need 1968, we can scroll back and forth. So, now, you scroll down here. It says, how many years did it take for the annual household income to double from its value in 1982? So first of all, we need to find the value in 1982. The value in 1982 is 19,032. So what we have to do here, we can use our calculator. We have to double that value. So we'll take 19,032 times 2. So we had 38,064. So what we have to do is find the year that is closest to 38,064. So we scroll up here. The year that's closest to 38,064 is 1998. So it says how many years did it take for the annual household income to double its value? So we know it was since 1998. So what we would do is we would say double the 1982 income is $38,064. Let me put the comma in here. So we had $38,064, which occurred around 1998, 16 years later. So what we would do, since we know that happened 16 years later, we will come here and we would of course mark our answer, which would be D. Okay, now we come down here to number 2. It says how many years did it take to double to the 1982 value? So we look here at 1982. We have 19,032. Now it says here how long did it take to double to that value. So we had to take 1982's value, which is 19,032, and divide it by 2. Because what we're trying to find out is what the original number was, and then double that gave us the 1982 value. So what we're looking for is the number that's closest, or the year that has the household income that's closest to 9,516. And that year would actually have to be 1974, because 1974 is only about $400 off. Now, so we will go here and we will type this in. So we will type in half, or write in the 1982 income is $9,516 which came around 1974. That was 8 years earlier. So now we will mark our answer as 8. So we will circle A, and that is our final answer. Now we scroll down to 2B here. Now with 2B, it says justify all answers with mathematical work or written explanations. It says here, number 1, which one of the following represents 35 million in scientific notation? So first of all, we need to write out 35 million. So it's 35 with 6 zeros. So that's 35 million. Now we know that scientific notation must have one digit in front of the decimal that's higher than 0 and only goes up to 9. So it's from basically 1 to 9 that has to be in front of the decimal. So that number here, we know we will put our decimal here because that number here would be 3. So we know we would have 3.5. Okay, now, so to get to 3.5, we know we had to go 1, 2, 3, 4, 5, 6, 7 places to the left. So it'd be 3.5 times 10 to the 7th power, which happens to be A. And that is our final answer. Now we come here to number 2. It says, which of the following is not written in scientific notation? Now, just as we explained up here, you're going to have one digit in front of the decimal, and that digit cannot be 0 or negative numbers. It just has to be from 1 through 9. So if we look here, A has one digit in front of the decimal, B has one digit in front of the decimal, D has one digit in front of the decimal, but C has 2 digits in front of the decimal. So your answer is C. One other thing to clarify on scientific notation, in addition to what I said here, you must also have this value multiplied by 10 to some power in order to be scientific notation. So now we go here to lesson 2C. Now with lesson 2C, it has the same instructions as the previous lesson, but we're going to go through this. It says, suppose you have a Twitter account with 120 followers. You want to impress your friends, so you purchase 1,000 fake followers from a shady online company for $18. What percentage of your Twitter followers are actually real? Round to the nearest whole number. Now, you actually had 120 followers. Those are the real ones. You added 1,000 fake followers. So basically that gives you a total with the actual and the fake followers of 1,120 followers. So we want to find out the percentage, and we know percentage means we're going to divide, of your Twitter followers that are real. So our denominator will be the real and fake followers. Our numerator will only be the real followers. So we would take 120 divided by 1,120, which we could put in our calculator. Which would give us, if we round this to the nearest whole number, now we know as a percent, we will write down to 0.107, and we will round that. But just to make it simple, whenever you're rounding to a whole number or a whole percent, you would just go to the third digit behind the decimal, and if it's 5 or more, you will round up the second digit behind the decimal, or if it's 4 or less, you would leave the second digit the same. So since this 7 is 5 or more, we will round the 0 up by 1. So that would give us 0.11. And then when we write our final answer, that would be 11%, which would be D. Number 2, 4 out of 5 Facebook users report that they have never bought a product or service as a result of an ad on the site. What percentage of users have made a purchase as a result of a Facebook ad? So 4 out of 5 did not. So that would leave us 1/5 that did. So 1/5